you have not done, unless you've been in physics, you have probably no experience with parametric equations. And when you talk about in physics class, the velocity in the x direction and the velocity in the y direction, you're talking about parametrics. Okay, you're going to have t-values. Another thing that we're going to do with this will be vectors. Matt, I need you to pay attention because this is new material. Vectors and parametrics will be a similar thing. This is a guarantee. It's on the exam. It's on the exam. It's guaranteed. 100% chance. Well, it's 100% chance for every topic, but I'm talking about previous times. It's always been on the exam. Okay. So what are parametric equations? They are pairs of equations, and the x-coordinate is defined in terms of time. So my velocity in the x direction, well, when will I be at that position? Looking at time there. Okay, so not only do you know where you are, but you know when you are there. So if you want to know if the two cars are going to have a car accident at the corner of 101 and 7, you have to be there at the same time. Okay, so you need time. We can write these pairs of equations without t. I can actually find y in terms of x, which is actually helpful. Well, let's go ahead and graph this graph by hand. Let's let the time start at -3 and go to positive. So I can table all set up for you. Okay, and then we're going to look at domain and range. So when I substitute in -3, I made nice numbers, easy numbers. I don't necessarily know what this looks like. What's the x value? So you should be doing this with me. Okay, so write it down. We're going to put this on a graphic calculator too. That's why you need it today. This is going to be 4, right? Notice the square these. 1, 0, 1, 4, 9. Just want to make sure I don't get this fast. Okay, and on the y values, each y value increases by 2. The time plus 2. -3 plus 2 is -1. -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. This always works. You're going to find some hard problems. 1 plus 2 is 3. These are going up by what? Okay, now let's graph this. Hey guys, if you can't do that, I'm going to have to just take right over there. Okay. So we're going to have an additional component there. My x's are going to go between 0 and 9, and the y's will go from -1 to 5. So actually, I can slide my graph over a little bit. Because the x's, are they ever going to be negative? No. And what's going to happen is we're going to get a picture, probably, of something not a function. So you can actually go to parametric mode to graph relations that are not functions. You can do a circle, and that's really cool. Okay, so when t is equal to -3, my x value is at 9. You really should be doing it with me. And my y is at -1. And I have to do that. Negative. So 9, -1. And I get the direction it goes as well. So when you do these problems, even if you're using a graphic calculator, you know the direction. When time is -2, and I could say t equals, when you're doing a graphic calculator, and say -2. Then I want to graph x equals 4, and then y is 0. 1, 2, 3, 4. Then at 1, when I'm at x on 1, I'm at 1 on the y. When I'm at x of 0, I'm 2 on the y. And let's see, when x is 1, I'm back to 3. Let's put this on a graphic calculator. 4, I'm at 4, and 5, I'm back at 9. So what's this doing? You're seeing the motion here. It's a parabola on its side. It is not a function. Now, I can't necessarily look at x equals t squared, y equals t plus 2. I can't necessarily look at that and say, oh, I know what that's going to be. But I can eliminate the parameter. Okay, first, before I do that, let's look at the domain and the range. And actually, it should have stopped at 9, so that's where it stopped. And I can go back to x equals t squared. What's going to be x is the domain. What are the x's going to be there? No, x wasn't 0. Yes, 0. And it actually, in this particular case, we stop at 9. But you're right, x can always be a positive number. And the range, what were the y values? Starting at -1 and going to 5. You have to look at your parametric equations to come up with your domain and range. Because I can get some really cool things with the trig functions, but it's limited. The trig functions are limited. It's not supposed to be. So should we put this on our graphing calculator? Does everybody have one? I have 5 up here. Now, I'm not going to use the inspire because it doesn't show the motion. I don't understand why they did that, but they did. Okay, let's see if I can find my calculator. I think in the past. It's just kind of a counter. I got 5 in here. Oh, the pink one? Okay, there, red stop light. I think. No, is that it? Yes. Okay. Has everybody got a calculator? If you don't have the new operating system with an 84, make sure you get it from me. You got a calculator? Okay. That's great. Okay, the 84s actually work better. Because I don't know. Most of you have not done parametrics. Okay. Okay, guys, Matt, press mode. And we have up here function, parametric, polar, sequential. We will learn how to use all those modes in this class. Yeah, we've only done function mode. So we're going to go to parametric. We're going to do polars, but not polar. Press enter. Now, if you don't see the word next here, then you do not have the new operating system if you have an 84. And I can upgrade it. If you were my student, you should have it. Okay, now, look what's going to happen to my x's and y's. So it's now I have my x, and so I'm going to quit, and I'm going to press y equals, now it'll match. And x was t squared, right? Now notice, see this x, t, theta, n button? It is now a t. Pardon? And you have to have both x and y, or just know what to do. This was t plus 2, right? Now, I do like looking at the domain range so I can set my window. So I'm going to slide this. And my window, now notice it's got the counter in there. It's a clock. And we want our time to go from -3. Which what? These are parametrics. This is what you do with Sect. You're not only knowing where you are, but you're knowing when you are there. If you want to predict if there's going to be a collision, you have to be at the same place at the same time. That's suggested. Okay. This was, what's my maximum time we did? We did 3, right? And my t-step, I would go by 0.1. It doesn't matter, but you want it to be somewhat small. If you have it too big, it's not going to show up right. X max 10 is good. X min, I really don't need -10. Make it -1. Yeah. And then when you press graph, it's going to pull. You ready? Y max is 5. Thank you. But I'll make it 6. Okay, is that it? Okay, press graph. Now, if you want to see it move slower, let's change the speed. Let's make my t-step. I don't want to go 0.01. It's way too slow. Let's go 0.05. So what it's doing is every time at 0.05 increments, it's plotting a point. If you want to see it go slower, you have to make the t-step smaller. There'll be cool pictures we'll make. so now we have to watch this. Still going fast. Let's try. I want to try 0.01. Well, it could be the new operating system. That should slow it down. There it goes. And then it stops. Notice if it's faster. Is it going the same speed the whole time? No. Look at it again. Y equals. Okay, ready? Kind of slow there. Stop. Turns around and watch it speed up. This is not as good as some of the ones I've done, but we'll do. So how would I know it was a parabola? Let's see. Well, we can what they call eliminate the parameter. Okay, guys, ready? And this is going to be heavy on the quiz next Monday and on your test, because this is the only thing we can do. Eliminate. Spell. Check. Okay. I'll talk about that. Okay. Guys. Okay, let's get rid of the T. And it's not a linear system. I don't want the T's there. Some of you are going to solve for T in the first equation, which isn't really good, because when you do that, you get plus and minus. You can't forget that you get plus and minus. So it's easier to solve for T in this equation. So if I solve for T, I'll substitute it into the other one. And we'll do it both ways, actually, just so you get that. So x is equal to t squared, and then y minus 2 squared. In physics. You did it in math? Yeah, that didn't surprise me. Now, if you choose to do it this way, if you want to solve for t here, what do you have to do? Square root. Now be careful. This is not t. This is the absolute value of t. Because t could be a negative number, and it actually is -3. And you don't want the square root to ever be negative. So you have to force it into j of t. So t is equal to plus or minus the square root of x. We're not getting plus or minus from the square rooting. We're getting plus or minus from the square root of t squared, not from the left side. And then now I can substitute this equation. So y is equal to plus or minus the square root of x plus 2. One is the top branch, and one is the bottom branch. That's why the plus and minus is. It is not a function. If you want me to go back to regular mode, we can graph it, but it's going to be a static graph. It's not going to show you motion, which I forgot to do when I did this, because we should also, I did here, we should also say, well, we started here, and we went this direction. Okay? So it's a different way of looking at graphs. It's not necessarily easy. So we've got some more problems to look at. Okay, Matt, you have a question? Yes. You might find it in the homework. I don't know. Try it. Play the calculator and try it. I'd have to think about it. Okay. We're going to go to the next slide, which is your other half of this. You should have it. And it says 1.4. Not what I want. It's orange, salmon, whatever color that is. So, oh, I don't think I want that one. Find out. Okay. I didn't realize we did that. Okay. We eliminated the parameter. I did that twice. So now this one says 1.4. I corrected the name on my computer, but I didn't correct the name on the file. Sorry. Okay, ready? Okay. Our essential learnings are the 2-day assignment. You look at your assignment sheet, we spend 2 days on this. Then we get into review. So Wednesday's a homework quiz. Yes? But not including parametrics. Okay, so we have a homework quiz, 1, 1 through 6 on Wednesday. Oh, no, not 1, 1. Where did we leave off? 1, 3, 1, 4 through 1, 6. On Wednesday. Okay. Homework quiz. I don't think so. Oh, you can look. Homework quiz, Wednesday, 1.4 to 1.6. Okay, guys? I have to repeat myself a lot. Okay. I know that, but because you're making so much noise, I have to repeat something in class. Not, no. Okay. Our essential learning is to graph parametric equations using a calculator and by hand. You need to be able to do both. Now, usually this is going to be in the calculator section of this thing. But there's only 2 calculator problems, so maybe not. But they would give you an easy one like we just did. It wouldn't be terribly difficult. And you'd be able to change them to Cartesian borders and change Cartesian borders to parametrics. Graph a relation, not a function. By converting the parametric equations, you're going to be able to match a parametric equation with its graph by looking at the properties of the graph. Actually, it changes that property. So maybe not quite so much. There is a typo here. This should be x equals cosine t. Y is equal to the sine of t. So I asked you to find x squared plus y squared. What is that? X squared plus y squared. Well, what is x squared? It's cosine of t squared plus sine of t squared equals 1. What is the graph going to look like? A circle. And that's how we eliminated the parameter. I squared x, I squared y, and I added them up, and I got 1. So I know it's a circle. X squared, cosine squared plus sine squared is 1. Okay. We're going to graph this parametrically, and we're going to graph on the interval from 0 to 2 pi. And which direction is it going to go? Clockwise or counterclockwise? I don't remember. I can figure it out, or we can just look at it. So, what's our minimum t? 0. T max is 2 pi. At t step, usually 0.1 does the trick, otherwise we may have to go smaller. Okay, ready? So we're going to get our calculator out. And if you think about it, you can plot some points. I think I have something to say about tomorrow. Okay, so y equals, I want to make that cosine of t. So I'm going to clear this out. So x is cosine of t. I said that myself. Cosine of t. Y is sine of t. And the only way you are going to feel comfortable with this material on the quizzes and tests is to do the sine. Because this is brand new to you, for most of you. Okay, I'm going to graph that. And my window, my T min is going to be 0. T max is going to be 2 pi. It should be ahead of me if I'm going to test it. T step, let's try 0.1. See, if it's not slow enough, we'll have to change it. Now, we know it's a circle. What's the radius? 1. So what would you like for your smallest x? Negative 1? How about negative 1.5 or something? So x max, let's do that as 1.5. It won't be square. It'll be a little squished, I believe. You can, but it's going to be off the screen a little bit. That's the reason why I make it a little bit bigger. And this is going to be negative 1.5. And make this positive 1.5. I love the picture over here behind me. Kind of squished. There you go. Ready to grab it? It goes counterclockwise. But let's try zoom square and see if it'll fix it. Zoom square. The problem with zooming square is that it is a circle. I don't like that. So I could maybe fix it. Let's see, the x's are bigger. -2. What's that? You might be going the wrong way with this. There it is. You want the x's to be a little bit bigger than the y's to get your picture. Now watch the graph. It's going to go around a circle. It's going to start over here. It's going to go counterclockwise. So you yourself have to do this. Make that bigger. You're going to have to write in the direction. It's not fair, is it? It starts here. Why does it start there? Because when t is equal to 0, what is x? X is equal to the cosine of 0. And it's not 0. What's the cosine of 0? It's 1. Then when t is equal to, what's the y? Y is equal to the sine of 0, which is 0. You can always plot points. So it's counterclockwise. I will be looking for direction. And if you remember when we did a little of this last year, this is my class, when we did the schematics, and I went into this mode just to show you the speed and to show you what's happening. Remember the schematics, everything on one line. You see nothing. Okay, what about that one? What's x squared plus y squared? Well, x is cosine of 2t, so it's cosine squared of 2t plus sine squared of 2t. What's that equal to? It's 1. What's the 2 gonna do to my graph? I don't know. Well, let's use our calculator and find out. Okay, we want cosine of 2t. So I'm just going to go in here and insert 2t. Yes, F. Because I'm graphing x and y, I'm just showing you that if I got rid of the t's, I get cosine squared plus sine squared. So 2t. I don't even have to close the parentheses, so forgive me. Whoops. 2t. And everything else should be okay, right? Now, the only thing I'm going to do is I'm going to go up here. I'm going to change this, because I can, to one of those circle trace, that one, so you can see it. You ready to graph? You just go over to the left side and press enter, and it'll change. I don't remember which one this is. Okay, graph. It will slow you down. There it goes. It goes around one complete time. And now what's it doing? It's going around twice, isn't it? What does the 2 do? It should go twice. Because what's true about the period? You get a complete cycle between 0 and pi. So 0 to 2 pi, you better get it twice. You want to see that again? So all you have to do is go into y equals. All you have to do is change something. You don't have to change it, but rekey it. You ready? And you get the motion. It's just going around the circle. The Ferris wheel problem. Oh, we didn't Ferris wheel. So it goes counterclockwise. What do you think would happen if I switched x and y? What direction do you think it would go in? If you make y equal to the cosine and x equal to the sine, it should go clockwise. What? Try your calculator for a while, too. Why would it? Okay. one. Now these are just like the homework problems. Man, these are just like the homework problems. Would you like to eliminate the parameter first or just graph? Now let me rewrite this a little differently. X is equal to the sine of t. Y is equal to the sine of t squared. I'm going to warn you right now. Do not use inverse sine because I'm going to mark it wrong, even if it's right. Because I want you to see what it is. I'm going to use plain old substitution. The sine of t is x, right? So in place of the sine of t there, I'm going to put in the x. Now, be careful. We're saying, oh, it's just a parabola. However, let's look at the domain. What's true about the domain? It's the x coordinate here. X is going to go between what and what? No, sine. Negative 1 to 1. And the range, since it's sine squared, is going to go from, what's the smallest sine squared will be? Suddenly square. What if t is 0? What's the sign of 0? 0. Is y going to be negative at all? No. But it's only going to go from 0 to 1. So I could sketch it. Let's make this one because it's too small. And so it's going to do this. It's going to go up here. It's going to be a parabola. And it's just going to be going back and forth. Be careful with these. Yes, it's a parabola, but it doesn't have all values that a parabola would have. It is restricted by your original trig functions. So let's graph that. Well, let's graph it. See what I'm talking about. Okay, so y equals, x is equal to the sine of t. And then y is equal to the sine of t squared. I'm just going to clean that out. Those parentheses, you can't do sine squared of t, it doesn't know what to do with it. That's just a math thing. It would have been nice if they'd made it so way. And then squared. So it's got to look like that. And since we have the domain arranged, we can fix our window. Can't we? So, should we go 0 to 2 pi, so I'm okay. I left the t step wherever it is. And then the x min is going to be, well, negative 2 to 2 will work. And the y min, so I think this will work nicely. My window's pretty good, actually. Ready to press graph? You can. You could put a 4 in front of the sine of t. Then it'll go 4. But you're always going to have this, which is going to stretch that. What happens if I make t max bigger? Let's make it, should we make it 4 pi? It does. That's why you have to watch it carefully. That's why I put the little circle on it so you can see what it's doing. Now it's going to come back down. It's like a pendulum. It isn't following pendulum. It's going to keep going, right? How would I write what? You can't. You got to do what I did. It would go, it does more times. If I make it 6 pi, it'll go through the cycle more times. And actually, where does it start? It starts at 0, it goes up here, comes around, does this. I mean, there's no way to convey that to me, really. That's the xy plane. Okay, Descartes was the guy who started graphing in the xy plane. This is x, y. And So these are Cartesian coordinates named after Descartes. Vocabulary is kind of important. Okay. Now, let's look at the next one. The only way to graph example 3 is using parameters. So you have to figure out how to do that. Okay, James, how am I going to do that? I have x, kind of small, x equals y to the fourth minus 3y squared. I want x as a function of time and y as a function of time. So x of t equals what? And y of t equals what? What do you think? James, what are you going to do? One of them's going to be t. I can't solve for y. It's y to the fourth. I don't know how to solve for y. You just want to write it with just a t. I let y be, if I let x be t, does that work? You can factor it. That doesn't matter. You can't do that. How about y is t? Then what's x going to be? T to the fourth minus 3t squared. We have to write it in parametric mode because we can't graph it. It's not a function. Aren't they the same? You decide. Nobody decided. This is mathematical. If t is equal to y, can't you put y right in there? And in here? And don't you get this? We're working backwards from eliminating the parameter to creating the parameter. Shall we try it? I know it's going to be, I don't know, I think it's going to be a W on its side. Because I know what y to the fourth was, at y equals x to the fourth. It's the inverse. You can do it inverse. That's one way to do it. You cannot solve for it. Okay, so I'm going to put my place. Okay, so I'm going to put in, I'm going to clear that out. And you can play with it. That's an interesting function. This was t to the fourth minus 3t squared, right? Now mine's pretty print. Yeah, I know, because I always keep writing up an exponent. You got to arrow down to the right, and it's minus 3t squared. And then this is going to be t. So where you see a t in this top equation, I can replace it with y, so it should match. Oh, that's... And did I have a domain at all? What's true about the x values? Are they ever going to be negative? No, because it's y to the fourth. Well, it might be. It might be, because minus 3y squared could be bigger than y to the fourth. I'm just going to grab it. Okay, not very good, is it? Okay, so now let's figure this out. Yes, x could be negative. It's still going. See, it's thinking. Okay. Window. I don't want my t values to go that big. How about some negative values? How about negative 2? Because 2. We're just going to play with it. T-step I'll leave alone and make it 0.1. I don't care. Y min is negative 1. Looked like that was going to fit. Y max is going to be bigger than 2. So we make it... How big is x going to be? What's x? X is t to the fourth. So if I let t equal 2, 2 to the fourth minus 12 is 4. Did I do that right? And then the y's are just the t values. So the y's have to be from negative 2 to 2. Oh, cool. I got to fix my x values. I didn't get small enough, did I? So let's make the window on the x's. Let's go to negative 5. Now yours graphs smoother than mine, doesn't it? It's not so choppy, is it? I don't know why it's so choppy. There. It's a W. Did you ever? If I were to rotate it, the original function, there it is. It's a W. Because that would be y equals x to the fourth. X equals y to the fourth is this. Reflection over y equals x. Did you notice the speed at all? Did you notice the speed? Because what's happening here at these points? It's stopping. Watch it again. I think they're fun. You're going to find this on them. See? Now it's going to stop. Mine's choppy. And it should speed up. Speeds up. If I make the window bigger, you can see speed up at the end. Okay. So do you see what you have to do? You have to now rewrite this with t's in it. So the only thing we can really do is probably let one of these variables be t. Anything else? Okay, here's homework problem 1. I think it's 1. 1 out of the old one. Might not be 1 out of the new one. Anybody want to verify if that's problem 1? Or we can do problem 1. Anybody open their book and see? No. I don't even know if they've been ordered yet, to tell you the truth. Yeah, that's mine. Is it a different problem? Let's do the real problem. X equals what? Okay. Well, let's just do a homework problem. You can read more about the cycloid. These are all in here, too. Number 1 is x equals t squared plus t. I don't even know if I assigned one, but I would assume. Now, these are not really meant to be done with a calculator. You can certainly check, but you should be able to do it by hand. So we're going to do a table of values. So this is God. Mine was easier. And so I'm only going to do whole numbers. Or integers. And then there's no product. This can always work. So t is negative 2, negative 1, 0, 1, 2. Here's x. So x is t squared plus t. So it's negative 2 squared plus negative 2. What's that going to give me? 4 minus 2 is 2. So you want to just do all the x's first? Negative 1. Negative 1 squared is 1 minus 1 is 0. 0. You might have to do something between negative 1 and 0 because something's obviously happening. I think it's standard. 1 is 1 squared plus 1 is 2. 2 squared plus 2 is... Okay, let's do the next one. Okay, negative 2. Negative 2 squared is 4 minus a minus 2. So that's 6. I think they're going to be opposite, aren't they? Negative 1 is 1 plus 1 is 2. 0 is obviously 0. 1 is 0. And 2 is 4 minus 2. They are opposites. That's kind of interesting. Okay, so 2 and 6. 1, 2, 3, 4, 5, 6. Then x is 0, y is 2. So it's going to go this direction. And then it's going to go 0, 0. then it's going to go 2, 0. That's right. And then it's going to go 6, 2. It's probably going to do something like this. So we find out. Your intuition on this isn't going to be great. Well, I might. Because I still think I would have seen it. Okay, so let's see how off I am. Okay, there it is. Y equals, clear that out, t squared plus 2. Plus 2 plus t, sorry. And then this was t squared minus t. I just plot the point. See where you start. You start with t equals whatever it was. Okay. We're going negative 2 to 2. We already know our values, so I've got to go up with 6 on both. And probably some negatives, because I didn't test anything in between. I know I got to get to 6. Be safe, I'll do that. And 7. Ready? There it is. My picture wasn't too bad. That was good. Now look at that. That's not bad. Yep, you don't plot the t's. You could label it. Oh, let's look at that graph. Let's do a trace. Now, here's the bad news. You guys, if I go up here the second to calculate, it doesn't give me zeros. It doesn't give me any section points. It doesn't give me any of the good stuff the function won't say. I haven't tested it on Inspire. My guess is it probably works better. But, so if I go back to my graph and you press trace, it'll be where you start. It gives you the two equations for x and y. It gives you the time. There's the cursor. It gives you the x and y position. So if I just arrow to the left, or right, sorry. See, it's counterintuitive. The object's going left, but I'm pushing the right arrow. Isn't that cool? Which element you pick up is time. When is it there? Plus, that's not a function. You start, you have to go in order. So when you do the direction, you have to start with t equals to negative 2, so you have to start that point. So yes, you will always get the direction. Okay. What are the similarities and differences between relations that are graphed in Cartesian plane using Cartesian form and those using parametric? Times be negative, you could say, where were you yesterday? You know, it's just like saying the fourth dimension actually is time. But a four-dimensional cube doesn't really look like that. That'd be fun to find if I could find a video of that. Okay, so your job is to do whatever day 1 on the assignment sheet is. And so problems 1 through 4 are graphing them. And then 5 through 8 are eliminating parameters. Did I assign number 7? So maybe we should look at 7. Might as well. We only have 2 minutes left. Yes. That's the X and Y. And we talked about Descartes a few minutes ago. Okay. I think I put it on Schoology. I don't think that the district can save you any money by purchasing them in bulk. Maybe $4. But I know for a fact that they're going to charge you sales tax. Whereas if you go to the website, I didn't see anything about adding sales tax. So I believe I put it up on Schoology. If you just order, you just have to pay shipping and the calculators. You cannot buy a cast in the United States. You have to go through a retailer because they didn't release it in the United States. I don't know why, because cast is all over Europe. Yeah, you can. You have to buy, go on website still. Yeah, I thought I put the link there. If not, I will. I'll make sure. Okay, guys, I don't really know what this is going to look like, so I'd like to eliminate the parameters so I have an idea. By the way, what's the domain? No. 0 to infinity. And the range is everything, right? So I'm in the same boat as you. I haven't looked at this. Actually, I've never looked at this because I did the old one. So how are you going to get rid of the t? Okay, so if you solve for t minus t is equal to y minus 1. So positive t is 1 minus y, right? So x is equal to the square root of 1 minus y. Well, I don't know, that didn't help me much. How about if we do it the other way around? If I have x equal to the square root of t, then what's t equal to? X squared. Substituting that in here, it's y equals 1 minus x squared. So what's this picture? This is the Cartesian coordinates. What is that a picture of? Right. But we are going to restrict the domain because of the original problem. It can only be positive. So t has to be greater than or equal to 0 when you set it up in the calculator. So you're only going to get this. And the range will have a limiting value. It won't be negative infinity to infinity either. It's going to be this. Guys, please. I think you have to be careful with this because you have to go back and look at this because t is always going to be. Because t can't be negative, t is not going to be negative, the thing will have a limiting value of 1. That's why I don't think you have a half. So it's just going to be the red one. And put it on your graphic calculator and take a look at it. Where does it start? When t equals 0, x equals 0, and y equals 1. So it's going to start here and go this direction. Oh, are there questions? Are we okay with the parametrics? You think you're going to attempt them? They're hard. So we spent 2 days on them. Now, let's do 1/6. Are there any questions on 1/6? Were you okay finding the inverses of functions? Yeah, we're trying to fly through this chapter. So the plan is, I'm going to stop this up. And I'm sorry, I forgot to put together a smartboard. I don't know what